two-port network. Here we can see this is a two-port network. As its name suggests, it have two ports, that is port 1 and port 2. Port is the combination of two terminal, that is, here we can see this is terminal 1 and this is terminal 1 prime. So it forms port 1. Here we can see this is terminal 2 and this is terminal 2 prime. So it forms port 2. Port 1 is called as input port and port 2 is called as output port. Also, two-port network have 4 variables, that is V1 and I1 and I2 and V2. Z parameters, it is also called as impedance parameters. In impedance parameters, V1 and V2 are dependent and I1 and I2 are independent. Since V1 and V2 are dependent, so V1 is equal to Z11 I1 plus Z12 I2, since V1 is dependent on I1 and I2. Similarly, V2 is equal to Z21 I1 plus Z22 I2, since V2 is dependent on I1 and I2. The coefficients of independent variables I1 and I2 are called as Z parameters. So Z11, Z21, Z11, Z12, Z21 and Z22 are called as Z parameters. In matrix form, this will be V1, V2, Z11, Z12, Z21 and Z22 and I1 and I2. This is called as voltage matrix, this is called as impedance matrix, and this is called as current matrix. Let's say voltage matrix is represented by this, impedance matrix is represented by this, and current matrix is represented by this. So therefore, V is equal to Z into I in matrix form. Now there will be two conditions or two cases. In case 1, we will consider output port as open circuited, and in case 2, we will consider input port as open circuited. So case 1 with output port open circuited. Now when output port is open circuited, that time this I2 will be equal to 0. Now again, also we are considering only this V1. Now the equation for Z parameter is V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Now since I2 is equal to 0, we will substitute I2 is equal to 0. So here this term will be 0 and here this term will be 0. So what's remain? V1 is equal to Z11 I1. So here we can see V1 is equal to Z11 I1 only, and here V2 is equal to Z21 I1. So here we can see V2 is equal to Z21 I1. This term will be 0. So from here we can find the value of Z11. Z11 is the Z parameter. So Z11 is equal to V1 by I1 when I2 is equal to 0. This Z11 is called as input driving point impedance because it is the ratio of V1 and I1. V1 is the input voltage and I1 is the input current. So that's why it is called as input driving point impedance. Now this Z21, from this we can find the value of Z21. Z21 is also an impedance parameter. So Z21 is equal to V2 by I1. V2 by I1 when I2 is equal to 0. Since Z21 is the ratio of V2 by I1, where V2 is the output voltage and I1 is the input current. So it is called as forward transfer impedance. Now case 2. In case 2, we will consider port 1 as open circuited and port 2 as V2. So when port 1 is open circuited, that time I1 is equal to 0. So here I1 is equal to 0. Now again we will write equation for Z parameter. The equation for Z parameter is V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. But I1 is equal to 0. This I1 is equal to 0. So therefore V1 is equal to Z12. This will be V1 is equal to Z12 I2. And this term will be 0. And here for V2, this term will be 0 because I1 is 0. So what's remain? V2 is equal to Z22 I2 only. Now from here we can find the value of Z12. So Z12 is equal to V1 by I2. So V1 by I2. Since this is a Z parameter and it is the ratio of V1 by I2. V1 is the input voltage and I2 is the output current. So it is called as reverse transfer impedance. Now Z22 is equal to, from here we can find the value of Z22. So Z22 is equal to V2 by I2 when I1 is equal to 0. Now since this is also a Z parameter and it is the ratio of V2 by I2, where V2 is the output voltage and I2 is the output current. So therefore it is called as output driving point impedance. Here we can see when Z11 is the ratio of input voltage and input current, that time it is called as input driving point impedance. And when it is the ratio of output voltage and output current, that time it is called as output driving point impedance. And when Z parameter is the ratio of output voltage divided by input current, that time it is called as forward transfer impedance. And when it is the ratio of input voltage and output current, that time it is called as reverse transfer impedance. Z parameter is also called as, it is also known as open circuit impedance parameter. Since there are two conditions and we are open circuiting or open circuiting port 1 at one time and port 2 at another time. So that's why it is also called as open circuit impedance parameter. Again, the equation for Z parameter is V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. So when we take RHS on left side, so this equation will be V1 minus Z11 I1. Then this will be minus again. So minus Z12 I2 is equal to 0. So this will be a KVL equation. Again from this equation V2 is equal V2 and this will be, when this goes on left side, so this will be minus. So minus Z21 I1 then minus Z22 I2 is equal to 0. So this is also a KVL equation. So from this will be V1. So here we can draw equivalent circuit for Z parameters of a two-port network. From this equation of KVL, we can draw equivalent circuit for Z parameters of a two-port network. So this will be V1. So here we can write V1 and this will be I1. This V1 is the input voltage and I1 is the input current. Now here we can see I1 is this is I1 and we have to multiply this by Z11. So here this will be Z11. Then this will be a dependent voltage source and it depends on current I2. So this will be Z12 I2. Now V2 is the output voltage and I2 is the output current. So from this equation, this will be V2 and this will be, here this will be a dependent voltage source. It depends on current I1. So this will be Z12 Z21 I1, this term Z21 I1, and then this will be the multiplication of I2 into Z22. So here we can see I2 into Z22. So this is the equivalent circuit for Z parameters of a two-port network.